Okay, so these properties are properties that you know. They just look fancy, and we have to dumb them down a little bit, okay? Because we use these all the time. We just always don't use the whole thing. For example, addition property. You use this every day in here. Well, I don't I don't feel like we do that because that looks fancy. What about this? How do I solve that? How do I get 7 to the other side? Add it. So guess what that is? It's called the addition property. Anytime you're having to add something to the other side, that's just addition. Well, likewise, if I have x plus 7 equals 3, how do I get the 7 across now? Subtraction. So it's just the subtraction property. Okay, multiplication. What about if it's divided? Then I can multiply to get rid of it, right? So that's actually the multiplication is opposite of what you see. And then division, if I have 2x equals 2, I would divide, right? Here's where they get different, but you've still heard of these. Reflexive. You see the same thing. When you look in a mirror, hopefully, what do you see back? Yourself. So when you're looking at this A right here, and you cross the equal sign, you're still looking at that A. When it's the same exact thing in the same order, that's called the reflexive. Then you have symmetric. This is when it swaps. So it was A equals B. Well, when you apply the symmetric property, then it becomes B equals A. Transitive is when, I call it, you cut out the middleman. Y'all learned these in Algebra 1 about this time last year. If A is equal to B and B is equal to C, then you can just cut out B and A is equal to C. So if they're both equal to the same thing, you can just set them equal to each other. Substitution. Plug it in, plug it in. So whenever you plug something in. And then what's the last one? Distributive. You use that all the time. It's whenever you're distributing something. So what I want you to do now is there are 9 statements down here. Write which property justifies each one. So for example, number 1, what happened? Not reflexive, symmetric, because it flips. So 1 symmetric. What about 2? Transitive, because it was A equals B and B equals C, and then now it's A equals C. Look at number 3. How did they get HJ by itself? What did they do to the 5? So that was the subtraction property. Now, same exact thing, so this is reflexive. What about 5? I kind of see 2 things. Actually, I like one better than the other. So it was measure of angle 1 plus measure of angle 2 equals 90. And it tells us that 2 is equal to 3. So instead of writing 2, they just wrote 3. So this is substitution. They plugged something in. Carson, are you with us? Number 6. What did they do to get 2 to the other side? Divide or division. Okay. What about 7? They were both equal to 5, and then now 5's gone. So what do you think? Yeah, it's the same. It's transitive. They just swapped the order a little bit. So it's still transitive because 5 is no longer there. What about 8? Close. Distributive. And the last one. Huh? What'd they do to get 3 to the other side? Not multiply. I hear Asia saying it. She's just not saying it loud. Addition. Addition. Okay, so those are some of the properties that we're going to use. Now, none of those are new. You've learned them at some point. You just have to remember them. Put your headphones on my desk. Okay, so this morning. I'm telling you a story. This morning, I got up. I went and brushed my teeth. My alarm went off. Then I went and put some makeup on. But then I clocked in at school, and I got here about 6:15. Then I had to get dressed and feed my dog. And then I started working on my door outside, homecoming week. But before I left my house, I set my alarm. Wait, what? I'm confusing you. What?
She's doing it out of order.
Why? I'm doing it out of order. But all these things happened. I did all these things. Is it not making sense?
The sequence you did it in.
It's the sequence I did it in. Okay? I'm flipping it on purpose because it doesn't make sense, does it? No. So, what's going to happen is we are starting proofs today. Carson, put your phone down. These are not bad. Okay? I actually really, really enjoyed this lesson. And I have activities on this lesson. And we're going to do this lesson for like 3 days because it's so important. And it's not bad. It's really not. Can you solve an equation? If you pass Algebra 1, you can solve an equation. Can you tell a story? Can you tell the order in which you took some steps? Then you're going to be fine. But it's imperative to keep the same order. Okay, flip the page. What do you see? Where'd you put them, Parker? Where'd you put your headphones? What do you see on the page? What do you see a lot of? Nothing. A lot of blank. Guess what that means? You're about to write it. Proofs take a little bit of space, but it's not bad. So we are not writing paragraph proof yet. We are only writing 2-column proofs. So what I want you to do is draw 2 columns. Okay? Now on this side, it's always going to be set up the same way. So over here, you're going to write statements. You're writing the statement of what's happening. And then over here, you're going to tell why. What's the reasoning behind it? So you're going to have your statement, and then you're going to write why. We are given this hypothesis and the conclusion. You are starting with the hypothesis, and it is your job to prove the conclusion. So we always start with the hypothesis, which is 2x minus 3 equals 8. The reason that we wrote that down, the reason we put 2x minus 3 equals 8 and not 4,000 trillion times 800,000 million, the reason we put this is because it's what we were given. We didn't just make it up in thin air, which kind of I did, but not really. We were given. So now, let's tell a story. What would you do next to prove this hypothesis? Okay, distribute. So, you see how I have step 1 for both, step 2 for both. So after I distribute, what do I get? 2x what? Minus 6 equals 8. So your reasoning is distributive. Or distribute. I like to put distributive property. P-R-O-P. What would you do next? Add 6. So isn't that the addition property? And if I add 6, some of you might like to write like what you're doing. You can if you'd like. So now I have 2x equals 14. What's the next step in the story? Division, divide. And what is the answer?
7.
X equals 7. Did we prove the hypothesis is true?
Yes.
Then you're done. That's a 2-column proof. Now, sometimes, the further off we get, sometimes they will have it in a different order. Like you might, don't write this down, but you might accidentally get 7 equals X. It has to be the same exact thing as in the problem. So if I had 7 equals X and I needed to get to X equals 7, what property is that? So be very careful when you're answering questions. You might have to flip it. Okay, let's try number 2. Same thing. You're just already almost giving up on yourself because you see fractions. Already. It is okay. So you use the same toppings or titles. Reasoning statement. So, number 1, first step is always whatever you are given. Well, I'm given, my hypothesis is that 7/2 minus n equals 4 minus 1/2 n. I just wrote the same exact thing. Now, your conclusion is n equals -1. So your n needs to be on this side. So move all the n's over here and move everything else away. So I would go ahead and add 1/2, so that's the addition property. I'm going to add 1/2 n. Could you make this into a decimal? Yeah, can you make it to 0.5 if you would prefer? So 1/2, 1/2. So now we get 7/2. What's -1 plus 1/2? You owe me $1. Someone gives you 50 cents to give me. How much do you still owe? So it's still minus 1/2 n equals 4. Okay, step 3. I need to get 7/2 to the other side. What do we need to do? Subtract. So subtract 7/2. Isn't that 3.5? 7/2 is 3.5. So you have -1/2 n equals 4 minus 3.5 is still 1/2. So we're almost there. Now technically you could break this into 2 more steps. Multiply both sides by 2 and then divide, or you can just divide the whole thing. That's what I would do. So I would divide both sides by -1/2. So what's n equal to? -1. Was that our conclusion?
Yes.
Awesome. We're done with this one. I'm not going. Not bad, are they? No. All right, go ahead and set up your table on the next one. On the back. Okay, go ahead and set up your table. Okay, thank you. Okay, so you have your statement. What's going to be number 1? Given. What's your hypothesis? Angle Y. This is what you're given. You can't look at this yet. You have to look at your statement and what you're given. You got to go in order. So we're given that angle Y is congruent to angle Z. Now there's this thing called, and I know we haven't covered this yet, so this is new. It's called the definition. I use DEFN for definition and proofs. Definition of congruency. That means when you see that something is congruent, you are allowed to say that angle Y, so the measure, let's say measure of angle Y, is equal to the measure of angle Z. So you can't just skip this step. You have to tell your story, and part of your story is that if they're congruent, then they're equal. So now that we know they're equal, we can use substitution to plug in the measures. So measure of angle Y is x plus 10. And measure of angle Z is 2x minus 90. Now, I'm not going to finish this, but I want you to finish it. Okay, so x needs to be 100 and x needs to be on the left side. So try to finish this one.